Hey all, in today's video we will break down the core concepts of foundation models, explore transformers and how they work, and give you an overview of prompt engineering, all through real-world use cases across industries. Whether you're aiming to become a GenAI engineer, data scientist, AI cloud architect, or machine learning engineer, this video will provide the insights you need to stay ahead of the curve. And this is part 2 of our multi-part series, so stay tuned in the series where we will guide you through mastering AI, ML and GenAI on AWS Cloud, covering cutting-edge topics including AI agents like Bedrock, which is one of the most in-demand skills in the field today. And if you have missed day 1, make sure that you watch the video by clicking the I button over here. And by the end of this video, you will have a clear understanding of foundation models, transformers and prompt engineering, which are essential basic concepts in AI ML and GenAI. And what's even more exciting, this video is part of our AI ML track job oriented program, where professionals like Utkarsh, Shrija, Debashish, Roshan and many others have successfully landed high paying jobs and top certifications in AI. And here's something you won't want to miss. We are hosting a free 90-minute masterclass on AI ML, GenAI, data science and Agentic AI, where we'll reveal a proven 3-step framework to help you secure a high-paying job in the AI field. So don't miss out. Register now using the link in the description and pinned comments. So let's dive into the video.
Today we're going to talk about foundation model. Now, if I really tell you that this is a topic which is less understood even by experienced people. Okay, so when I was doing some kind of interviews, I was very much curious to know how much people understand what is happening when you are talking to a chat GPT. So I will tell you 9 out of 10 people were not able to really articulate it. Let's take this as a challenge at the end of the class today. You will be better off than anybody outside in trying to articulate what exactly happens when you type something. So before we go to that mystery, I just wanted to ask you a very simple question. And let it be a little bit different question so that you answer it. And I wanted you to think, because in this fast moving world, social media, we have stopped thinking. If you just step back, think a while, what are you trying to do in ChatGPT? Otherwise, you can't have any value for this particular session. Number one, if I ask you how many colors are there in the rainbow? Okay, simple question. Can you please put that on the chat, your answer? Okay, so I can ask the most silliest question to all of you and you have all answered it. Now I'm going to ask you a difficult question. How did you answer this? Because I just asked you a very simple English question. How many colors in the rainbow? And then you put 7. Memory. Sakshi is telling memory. Can you give me an answer? How did you answer this? Based on knowledge, Srinivas is telling. We learned it from childhood. Okay. It was fed on to you, Prabeen. Let's take more insights. Suppose you want to go deep from school, read in articles, teach in schools, home. Any differential answer. How did your brain work to get this answer? Have you thought about it any point of time? Because you don't have one memory, you don't have two memory, you have hundreds of things stored. But when I asked a simple question, you're able to really put together this particular statements like how many colors in rainbow, and quickly you're able to wire it and give me an answer called 7. Okay, and if I change the question, which color you like in rainbow, that also you will answer very quickly, which can be personalized. If I tell you, please draw a rainbow, you'll also draw the rainbow. If I tell you, please create a video of the rainbow, you can put together something. So you're very fast. Can you imagine if you want to do this to a mission? You are trying to go deep dive into the product development of an open AI. Maybe those are the guys who are getting paid the most, right? The engineers who are building the chat GPT for us. So we all must be curious if you are in the foundation models, irrespective of what you do, multi-cloud, whatever you're doing, to know what exactly is happening. So we're going to see that today. And what I've done is I've giving you some live demo of this today. in terms of telling how this is unleashed. So there's a PowerPoint which Sahid had shared. Use that as a reference point. I'm not a parrot to just read PowerPoint from start to the end. We'll use this as a reference point because you're beginners. But we will try to see multiple links, and those links, please bookmark them. Don't wait for somebody to send. When I'm putting a link there, just bookmark that into your browser, and you can see that later part to understand it. And that is Yogi who's saying neurons connected together to get it from stored. That's a fantastic thought process. So you're talking that your brain is a deep learning networks, neurons are connected, there is a memory, and you were able to take these words, which I just spoke in plain English. I can convert this to a Latin language, I can convert to a Spanish language, it doesn't matter. Whatever language I tell, you're able to really wire it if you're aware of it and give an answer. That's really magical. And if you ever try to write yourself how to do it in your lab or your product management, you have to understand what's behind the scenes. We'll see that in a short while. So before we go there, foundation models. What is the meaning of a foundation model? Try to understand. So foundation model is like a lateral hire. Okay, so I give you the same simple example. You have freshers. You create a model for a fresher, you have to train it in your factory. That's called machine learning models. Foundation models or like lateral highs, they come with a lot of knowledge, billions of parameters of knowledge. Okay. Now, when you have so much knowledge, the only thing you need to do is to ask questions because you don't have to train a lateral hire on basic things, but still he has to understand a little bit about your company, your part, what are your projects you're doing, what is your delivery practice. That's where the concept like RAG and enterprise relevance comes. Basically, they know it all. Okay, so foundation models is a large AI model trained on huge amount of diverse data, text, image, it could be code, it could be audio, which can be adapted or fine-tuned for many different tasks. It's like how you're answering. I ask a question about rainbow, then ask what is the weather in this. I ask something else irrelevant. I talk about today is Sunday. How are you attending? We have a psychological answer, but how are you answering so many questions? Because your general purpose, you have knowledge built over time. And whenever I ask a question, you're able to relevantly take it from your memory, from your neural network, etc., and then place it back. Okay. So imagine you have to do that in a factory setup. So what you have to do is to use concepts of AI ML. So that is the reason I tell you cannot ignore the big brothers and jump into generative AI and tell I'm a very smart kiddo. I don't have to know anything basics. I'm doing wonderful jobs. Not going to happen. Down the line, when you want to build your own foundation models, when you want to really create some high level of customization, personalizations, these concepts are very useful. So a foundation model is a large AI model, huge amount of diverse data. It is called foundation. Why? Because it's a base layer where you can build any kind of applications. Okay, so instead of you training the model from a scratch for every new problem you're facing from customer, you can always reuse and adapt the foundation models so that it can be used for multiple things. We'll see several examples. Yesterday, I gave you a link for the GCP. How many projects have been built on generative AI? You can refer them. Like, what is that kind of things which are built? So what do you mean by trained and broad data? So pre-trained at scale, we look at it. It means it's trained on massive data sets, billions and trillions of tokens. We'll talk about that as you get deeper into the subject. It means I can take a foundation model and give it as an input of, imagine Facebook, how much data it has got. So the Meta company is having Llama 3, which is a foundation model, which is trained with huge amount of information which you're putting across onto the public domain, etc. And they all will be very loosely coupled data. And then you have those things available as an FM where you can ask questions. So imagine personifying a lateral hire is a human being. And if you imagine 1,000 lateral hires into one place where you're asking questions with all the knowledge, they're going to be looking very smart. So it's pre-trained at scale. So you will use massive GPU power. Okay. Now, we will talk about training in a while, Bala, don't worry. Because that's a separate topic of how do you train itself is a 2 hour class, and then we will be doing a lab on the training process. At this point, just get the pillars right, understanding that you are, for example, if you're using AWS, you will use SageMaker, you will use SageMaker model. In SageMaker model, you will take data from an S3 bucket or a huge amount of information from unstructured, structured data, and then you start training the model with all kind of combination. You clean the data, you bring all the data, and then start pre-training it. And you do it at the scale. It means it's not simply training it at low level. That is why yesterday when you were asking, will all the people have to go and create a foundation model? It's pretty expensive. Okay, it's not going to be easy for you to build your own foundation model. Okay, it is going to take time consuming, it's very expensive. And why do you need to do it if there are already thousands of foundation models available? Leverage them, customize them, extend them, create a small language model. Try to be more closer to the customer in terms of building solutions or the UX part of it, which is more useful. Okay, we'll be using SageMaker. It depends. You can use, see, if you end of this, yesterday and today, we are going to cover foundation model. You enter AWS, you will use one stack like SageMaker. If you go into Azure, you'll use a different thing. You go to GCP, you'll use it. That's tools to really implement the foundation models. At this point, we are not interested in it because from next week, we are getting into the tracks, which will be specific solutions for building with the foundation model, building AI, building ML. We get into the service stacks. At this point, first, let's understand what is this. Then only you will be able to use the tools and etc. Okay. Now coming back, whether the foundation model uses unsupervised learning, will be using SageMaker. We'll cover that in a while. If I'm going to anyway cover it, I'm just keeping that questions for a while. First, let's understand these pillars. Pre-trained at scale. It is general purpose. It is not limited to one task. It can answer questions. It can summarize the text. It can translate. It means you're training it for a lot of things. That's why it is foundational. It is very general purpose models. They're very adaptable. They can be fine tuned, prompted for specific domains. For example, medical, legal, coding. Imagine a model which is being coming out of a factory. It can do multiple things. So you are the ones, or I am the one who will test that model and check whether it's suitable for my project. If it is suitable, then I use it. If it's not suitable, I might shift over the different foundation model and choose the right one. If I really see 2 or 3 models are best for my project, I can pick 2 or 3 of them for your projects. Okay, so it's very adaptable, multi-model sometime, which means like it can handle text, image, video, and video together. Sometimes the models are only managing text, etc., etc. We will be seeing demo of all these things, so don't worry in case you're not getting a grip of how they look, because currently you should know what is AI, what is ML, what is generative AI, what is foundation model, what is prompt engineering as you exist today. Okay, and then learn a lot of literature about it until the next Saturday. Okay, because you never get this time. I'm telling you out of my sheer experience on the ground, the more you read research paper, more you learn about them on use case, the more better you can implement it on your show. Because tools and service are just implementation. They're as important as this class, what you're going through. So don't ignore this. A lot of people always want to really work on hands-on, hands-on. That is good. That is equally important to what you're learning about how it exactly works. As a tricky interview questions in an engineering interview or even at the base level, somebody might just ask you, how do you think ChatGPT is answering when you ask a question, how many colors in the rainbow? If you're anytime able to explain it neatly on a whiteboard, you almost got 50 marks out of 100. Okay, everybody knows that today SageMaker and any tools you're using to implement quite be a little more easier because they're all generated code. You just sort of work on it for maybe for 1 month or 15 days, you can catch hold. But engineering understanding is important so that you can be innovative. So it's large, it is self-supervised. For people who don't have background on machine learning, there are different types of algorithms which runs in ML. That's a separate class for it. So don't worry in case you don't know about it, we have different type of learning called supervised learning, unsupervised learning. You have learnings which are typically coming from reinforcement learning. In the world of foundation model, we use a concept called self-supervised. We will expand on it about what it means in a while. Okay. So different examples of these foundation model could be GPT, which is very famous. It powers the chat GPT. It's used for text generations, coding, etc. There was something which released by Google called BERT, BERT, widely used for search and language understanding. Stable diffusion generates images from prompts. Okay, Llama 3, which is there on the WhatsApp, it's an open source language model for research and applications. The Gemini, which is Google's DeepMind, is a multi-model that handles text, code, and images. I'll try to see how much I can demonstrate most of them today. It again depends on the time. So let's cover what is required for the day, and we will spend a lot more time seeing them, which will get you an idea like how you can build an app in 5 minutes. And if you don't believe me, I'll show it to you how we can build 5 minutes a complete app with on any platform, maybe on Python or Java, by using all these foundation model. And I'm doing it every day. It's not a big surprise. Maybe for you, when you're seeing it today, you might be feeling, okay, this is so easy, this is cool. Okay, now the question is, do you have to really do this? Is it really valuable? It depends on what you're trying to do. So understand what are foundation models. Think of a foundation model like a smartphone. Out of box, it has got many built-in capabilities like what a smartphone has, like a camera, GPS, internet. Now the developers like you can build some specialized apps on the top of it. It can be a banking app, fitness app, games. This is what a smartphone people do. You don't build a phone scratch every time you build on the foundations. So foundation models, if I ask you, why did you take a lateral hire compared to a fresher into the project, you know the answer. Because he comes with a lot of knowledge, experience, project experience. Okay, he's able to really take over quickly. So this is the first thing. And if you can even do a research, people have done research for years together on this particular concept before it is live. I would recommend uh, if you can research on foundation models, I'll leave you some links from my side. But end of the day, you must take that interest to self-learn about AI, ML, generative AI, and deep learning, etc., as you go deeper into it. Going back, this is how a foundation models or really work as a structure. Okay, so you give huge amount of unlabeled data. So whenever you're trying to create and build something with the foundation model, there are different type of data. There are labeled data, unlabeled data. So the reason why you will not use labeled data is it takes a little bit pain for you to build. Labeled data is used in some of the context, but for foundation models, we will use unlabeled data because you want to train foundation model with heterogeneous, multiple types, quickly, fast, with a velocity which is unbelievable. So you will use, uh, yes, we can see the PPT. I think you must just check your side, Parimala. And there was, I think, a question about customizing the FM. I think Sahid has answered it. We'll talk about that in more detail as we go forward. So there is an unlabeled data. You pre-train it, okay, and then you get your foundation model, which is you call it as Amazon's Titan. You can call it as Meta's Llama 3. You can call DeepSeek. They're all foundation model names. And then when you ask questions from your client side, it will give you any type of answers. You can tell, please summarize this paragraph for me. Please summarize this content for me. You can do it. Labeled, unlabeled data is not equal to unstructured data. Unlabeled data can contain structured data. It can contain unstructured data. You can contain IoT data, whatever it is. Okay. So that is how, Praveen, you think about it. Okay. So unlabeled data means you're not really trying to pick up a specific labeling for every data. You don't use some structure for it. You quickly want to leverage all kind of data. The question about can you deploy locally? Just think about this way. Why are we in all these classes? Okay, why can't we do everything? 15 years back, I think 20 years back, when I was managing a huge project in Java or in the early .NETs, okay, we used to have an intranet where we used to have a server, a client, and everything is deployed locally and you connect and do it. We are in the world of cloud, right? So the reason why cloud is powerful is you get a lot of power out of the cloud. So most of the time, larger projects, you should really leverage the cloud to use and consume the foundation models. And if you want to customize it, you customize the way you want and put it back to the cloud so that it can be used by people. But if you're doing something very niche, like for example, 6 months back, we did a small project for in an IoT space where the models will be used only by a specific set of people. So there you can take a raw foundation model, you can customize it, download that locally as a small language model, which will be a teacher student kind of relationship that can be downloaded. But if you download it locally, you are in pain of managing the non-functional side. You have to really manage the security. On the cloud, you get from the cloud provider a lot of ways by which the entire data is secure, etc. The best practice as well as the use case will decide whether you operate the foundation model directly, whether you will customize and operate it, whether you will create your foundation model, whether you will download it locally. They're all different use cases of based on the project. You can never tell this is correct, this is wrong, this is the way to go, but all these options are available. So and to answer your question, Gurier, you can deploy locally, you can really pull your model and put it back to the cloud. It all depends on what is the provisioning strategy you're doing at the end of the project. Okay. So now you have unlabeled data, you pre-train it, you have a foundation model, you adapt it to the broad range. Now, this is the most important part because when I asked you a question about rainbow, if I keep asking you 40 questions, for all of them, you'll have an answer. And if I keep changing the dimension of the question, still you'll have the answer. I am challenging you if any one of us have to create a foundation model and it has to respond to it. It is not an easy job. So that is the reason the engineers are operating and building this foundation model, which has to simulate a human kind of a thinking, which has to think, which has to answer. Is not an easy job. And they've already done it successfully. That's where you're seeing now these things getting used at the client side. It's very easy for me to go to ChatGPT or Gemini or any of this and ask it a question. But if you really want to understand the engineering side, which we will attempt to do it today, okay, success or failure depends on how much you can take out of those intrinsic deep dive knowledge. To really simulate it, we'll try to give you some links so that you can refer them offline because they will not be part of this what is there on the slide or in the labs. There are deep engineering principles which if you know, you look very good while you're answering questions in interviews or while you're preparing yourself for anything where there are challenging questions where somebody trying to ask you deep. Now, this is a very, these two slides are just a building high level view about for beginners because these two classes are supposed to be for beginners. What is AI? What is ML? What is Gen AI? What is foundation model? Foundation model is like a server. Okay. Prompt is like a client. We used to build, how do you, in very recently, 2 years back, I was working with one of the customers in the EMEA region. I don't want to name anything confidential. So they had an intranet. Now this intranet was using Java technologies where everybody were using SharePoint portal combined with Java. Very comfortable. So when these foundation models and everything coming, they want to convert the intranet into a prompt-based approach. It means like they don't want to have this like a server client. They wanted to really have everybody on the mobile phone and on everybody coming like a chat and then asking any questions, it should be able to answer. So they were early people who were building this intranet using the concepts like a prompt as the client, where any employees can ask any question. The server was a foundation model which they customized with the data of what they had. because the foundation model is very generic in nature. Like imagine you hire a lateral hire, you still have to train that person 1 month about your company's policies. If, so, for example, somebody joins K21 Academy, you might be a great person outside, but still, when he joins K21 Academy, he has to understand what's the company, what's the process, what's the policies, how do they work. Those are not outside, they're inside, right? So we train that foundation with all this data. That's a question you're asking, customizing, personalizing. Then the FM is ready for that particular task. Then now the client is asking questions. Now the FMs are not dumb. When you ask a question, it starts learning, self-learning what you're asking, and it keeps building the knowledge over a period of time. So that is how they become very smart. Unlike intranet where you're typing it, you update it, you increment it, you put a DevOps pipeline. That's not the way you try to look at. Now let's look at foundation model, how the foundation models are created. Now we will get Kaihan to all these aspects. You're right. Absolutely. You're right. Thank you for sharing that. Now coming back to how are the foundation model created, you take large amount of unlabeled data, you apply a training algorithm and foundation. I'll be a best person to talk about this because in my task list, I have done an FM creation. I was pretty lucky to do this. I've done it at the backend, but a very high level. First thing what you do in any of foundation model creation is data collection. So yesterday, people were talking about how important is data. There is nothing in AI, ML, generative AI without data. The first step which you do in foundation model creation is collect. Now, for people who are asking unlabeled data, we will talk about a separate slide, Albert and others. In the next slide is all about unlabeled data. Okay. And then after that, you will clear all your doubts. So don't worry. Just hold on for some time. Patiently listen to me because I'm just sharing my experience, not reading the slides. This is the slide you anyway will have. But I just want to talk about when I created a foundation model. That's the story you want to listen, right? Because it's recorded, you can listen to this once more as you get back, right? First step in any foundation model creation, data collection. Okay. Now this customer was creating a foundation model for a domain. He was extremely good in the legal side. The company was completely into legal. They have knowledge for last 3 decades. Okay, what the legal operate, but they did not find any foundation model very smart enough to answer legal question beyond a level. High level question it will answer. Okay. So what we did first was data collection. We collected huge, diverse data sets. And now the guy who is from the domain, especially the legal heads, they gave us books, websites, Wikipedias, images, audio, video, their documents, no confidential documents, because you're not supposed to go and take all the customer data and put it into it, right? It looks very silly. You'll be out of business. But you're building a legal FM. It means like it knows everything about legal in the public domain. You can take that same legal foundation model per customer. Suppose you're going and meeting a customer, for example, Bank of America. You take this legal FM and tell, now I can implement this foundation model into Bank of America, but the data what I use will remain inside the company. Okay, that is a customized model which you will deploy per customers. You have a standard generic FM. From there, you can have per customers, you can customize and deploy. That is a RAG to the beginning point, basically connecting the enterprise data to the base model, which has got large amount of general data, right? So we'll talk about that because the subject is so huge. I don't know how to keep my mouth shut. That is my biggest problem now. So take one thing, that data collection. The first step in creating foundation model. It took us more than 3 months. Okay, to really collect all the data relevant. So for anybody, yesterday we were asking, data engineering, data collection is very important in any of these topics. Because if you don't have data, you don't know how to clean it, you don't know how to take the messy data off, you don't know how to really create it for a project, you'll not be able to do anything big. And even if it's a foundation model, you're consuming it tomorrow, you might have to pull knowledge data about something, domain specific data for pre-training, post-training, you require new form of data, right? So understand data collection is the first step. If I look at stable diffusion, I have just done some research work on every model, how it works, how it goes internally. Stable diffusion was trained on image text pairs. Okay, similar GPT was trained on internet scale text plus code. So these are all internal secrets, but they will not share too much of information for you. But you will find some public information being shared, some research papers available. But forget that for a while. We are in the beginner class. Data collection is the first step. After you collect the data, what I did or my team did, which is a huge team, is about pre-processing the data. Okay. So you can, Francis, you can take the data from reliable source. You can buy the data provided it's a public domain. But what you will tend to do in phase 0 is to build a generic legal model for whatever. You can replace legal with whatever you want to build. You will build that model which is more generic in nature under public domain. Don't think like you're trying to put something very customized, personalized when you're doing the phase 0 of the AFM. Okay, because you want to release it and test it properly. And then you can have an ability to customize it, wrap it with a kind of layering, etc., etc. Okay. So after you do the data collection, you will move into pre-processing. And now I am not talking a story. I'm talking what I did on the ground. Okay. So after we collected the data, we pre-process the data, removing duplicates, bad data, sensitive information, convert this into a machine readable format. Okay. We converted text to a tokens, images to a pixel arrays, audio to a spectrograms, etc., etc. Because there are a huge amount of recordings available about different things. People were talking about legal laws. We wanted to convert them. So data collection, whether it's structured data, unstructured data, okay, first collect them. Then you do pre-processing. That's what Narendra is talking about. You clean it, okay, and then you convert it. That's pre-processing. And after that, you will choose a neural network architecture. Now, this might be very surprising for you because a lot of people don't know this. Imagine today the model architecture selections is de facto to transformer. Tomorrow, it need not be. So whenever I tell model architecture selection, what I mean is you will choose a neural network architectures. So what is very common? 90% of us will use transformers or the most common. So here you will tell what is the model size, layers, depth, parameters. For example, GPT, if I remember the older version 3 had 175 billion parameters. GPT-5, which is released today, is more than 300 billion parameters of information which it can store, right? So that's the model size we are trying to talk about, which is unimaginable. So basically, when I talk about today MCP, the model context protocol, which comes from Claude. So everybody is using MCP because nobody has invented the
MCP.
Okay. Similarly, the model architecture, when you talk about, we all de facto to today to transformers. Because that's a very commonly used, that's the only one which people are using it today. But that can be multiple things coming up down the line. Okay. So let's repeat the steps. MCP stands for Model Context Protocol. So I've used the jargon. Let me expand it. We are in the world of agentic AI. You might have multiple foundation model you're trying to use for a project. Now, the way you will build the solutions when there are multiple FMs, you want to standardize the protocol, how they communicate with each other and do autonomous decisions. So the Anthropic company, the Claude, they came up with a protocol called MCP, which they have open sourced it. Anybody can use it. Basically, that is for model context protocol. That is very famous in today's development, today's agentic AI world. I just used it for one reason, that what is the alternative for MCP, because it is very new, is nothing. You have only few of them which is under development. Similarly, today when you talk about transformer, everybody is. So when I ask a tricky question to somebody in a student, like, what do you think? What is the model architecture you can do outside transformers? You tell that they cannot even visualize this question, because everybody is telling the model architecture selection is always only transformers. It need not be. There are other ones in pipeline. Tomorrow you might have plenty of them in choice. But currently, just think the architecture of the model will be using transformers as the approach, because it came from attention is all you need. From there, it started about transformer, but people are reinventing, etc. Okay. Now,
Can you repeat that again, please?
yeah. So first step is data collection. The second step is pre-processing, which is removing duplicates, bad data. The third step is model architecture selections. It means you have to select, you have to process so much of data. What is the neural network architecture you will choose? 95% of the time, transformers are most common. Okay, what are the alternatives? There are something from Google which is very locally done. Some of the open source people are doing. Just ignore them for a while. Just imagine your neural network architecture for most of the foundation model processing will be transformers. Okay, and you can configure them a little bit, not too much. We'll talk about that. Don't worry, just be a little bit patient. I just want to give you the steps: data collection, pre-processing, model architecture selection, which is transformer. After that, we have something called pre-training, right? Pre-training is the fourth. And the last one is fine-tuning and deployment, right? So let me just take, this is a very good point. Sorry for that. It is available to me on the Word document, and this is outside. I will just pass this into Sahid so that they can share that with you also, because this may not be available directly for you. Okay, so we'll send this document to you so that all of you can read this document, which is about data collection, pre-processing, model architecture selection, pre-training, and then fine-tuning, adaptation, and deployment. So any foundation model architecture you're going to see creating a foundation model will go through the steps exactly what we are trying to share. Okay, now don't feel that you are not able to understand this fully. Most of the time, these things are not much covered in detail. So my recommendation to you is, because we are in the beginner week, these are the kind of content which the 80-20 Pareto rule, generally people will not know. I would recommend, you will not find this document. I will share this with Sahid. And maybe Shahid, you can put this content in some place so that people can benefit from this, because this is not anything confidential. You can always use this. Okay. We'll get this to you so that all of you can save. Let me save this as a content, right? Let me just save it as FM creation real time, because I had to take off a lot of content out of it for one reason, that there are a lot of confidential information which are there in this process. So that was the reason that I was pretty cautious that I don't just open up the document which I had on my system, but I was just trying to give you some notes. So let me repeat this for you on the slide. It's very simply put, like large amount of unlabeled data, training algorithm, you create a foundation model. In real time, you will have data collection, pre-processing, okay, and followed by model architecture selection. You'll have pre-training, fine-tuning, and deployment, and continuously learning through that particular process, right? So don't worry, we will have this document posted on you so that all of you can know how a foundation model is created. For your information, this itself is a topic which have to be learned separately. Now you're just getting introduced to it, so don't jump guns that you should know everything about it at this point. My only point was that you must know, like, you could create your own foundation model. Okay, it's not that always you have to just consume the foundation model. It is not very easy for you to on day one go and pull and go and create this. It was just a kind of an experiential sharing. Whatever is non-confidential to those project which I did, I will share it with Sahib and he will put that back to your WhatsApp and everything. Okay, clear with everybody? Let's move on. Unlabeled data. So 9 out of 10 of you were trying to ping on this about what is this unlabeled data. So unlabeled data will be used for at a scale for pre-training because it's easier to obtain. Because every time you're training, for example, in my experience of building this legal FM, you will not find that you get labeled data. It's so difficult. So you want to really pre-train at scale means what is easier, you will get a lot of these different type of data. So the latter, which is basically labeled data, will require annotations, tagging. Okay. So during the pre-training process, the model automatically takes context for all the training data. So unlabeled data is one of the preferred way. It is not that you can't do it with labeled data, right? But unlabeled data is going to make your life pretty smart, pretty easier. You'll be able to move very fast on it. Okay, this is a component which is very important. And I've given you a detailed steps which will come back to you. Read them also. And then what do? You create a large model. So with billions of parameter to store deeper context, large amount of data, and then you will get a large model which is available for you to use. And that is how you're today seeing. So let's see some models. For example, you're opening up. This is ChatGPT for you. Now you will see that when you're sitting in the ChatGPT, you are asking any questions, right? So you're asking what is the color, the same question. Look at what it answers. How many colors are there in a rainbow? Okay, now when you ask this question, it's able to quickly tell it's got 7 colors: red, orange, yellow, green, blue, indigo. In reality, it tells a lot more informations. It start probing me towards do this, do that. Do you need that more, this more? My point is, now there's a question, where do we get unlabeled data? There is no one source, Peter. You have to really hunt it from a public domain, internal information, experiential data, video recordings, audio files. For a project, you will figure out. If it's a meta, they know from where to take the data. If there is some other providers, they know how to build the data. So all these companies which are there today, so let's name some of them, Amazon or Microsoft. These are famous ones, right? But there are so many providers who create foundation models. And each of them use a peculiar way because they come from a domain. They use a peculiar way to collect this data in their own way. So there's no one way to answer that, but it will be a plethora of information they capture through different clippings, different video, different documents, which is available on public, plus this. They use all this data to train. It is not an easy stuff. How when I asked you, how did you answer there are 7 colors? Because you told me experiential, memory, childhood. So you have to build all those with how? By going to repetitive training, by going and talking to an organization, you met somebody, you spoke to somebody. Same thing happens here also. You have large amount of data and you have to then streamline this continuously with a lot of informations. So as you build one yourself, if you get a chance, because most of us don't get a chance to build their own FMs, if you get a chance, you will understand what I'm trying to tell. It's really cumbersome, very challenging to do it because the place you will get stuck is you're on getting this data for your enough data for you to really train it into the next level. So when you see this particular thing, what are you trying to do here? You're asking a question. So this is called prompt. And then it touches and goes and hits the GPT 3 or 4, whatever engine I want to start. It start answering this question to you. Okay. Now you should understand the slide which I was trying to show you, the GPT. In that is the foundation model. That foundation model has been trained about rainbow, right? So it has picked up the data from where? Because it understood that this is, you're asking about something like this. So I have to go back. I have to really understand that. So it starts processing it. It gives me the answer. Now, if I tell you, please draw a picture of a rainbow. So now it might just process and then start thinking about how a rainbow looks. So from a text, it might just convert that into information, which is basically to tell that this is how a rainbow looks like. And tomorrow, if I just tell that I just don't want, let me get the rainbow. So it draws a rainbow here. If I tell, can you create a simple video for me? If I enable the higher side of the GPT, it can create a smart video to tell that how I depict. Can you give me a PPT which I have to present to somebody about all about rainbow? Okay, and then I can become very controversial, asking it questions like, does rainbow mean something else also? So if so, you're checking that for the same topic, 150 things you can check, like how strong as at the back end of the foundation model is it sharing everything, is it not sharing anything, is it legally fit for any topics? Okay, so understand, this is what we are trying to talk on the slide. It means it's the client is, this is prompt. Okay, the server is the backend GPT. The GPT is the one which is trained with large amount of data, unlabeled data. That GPT will be, once it is trained with the data, it's pre-processed, it's cleaned. Okay, and then you start applying all the algorithm there so that it is ready to use. Now, when I ask this question, now the most tricky is what I'm asking, how does it understand it has to go and get? Because you did it, how does the machine do? That's a very, very, very difficult question to answer. We'll see as much as possible. We will try to cover it today. Okay, now look at like what it's like. Would you like to me place it in a sky scene with clouds and sunshine? If I tell yes, it starts drawing and make my visuals better and better before I get a picture which I can just download and use it as part of my information. We are not trying to understand here the English form of the learning. You must continuously think, how is it able to do this? Because it is unimaginable for us to think, how is it able to relate all what it is I am trying to ask and bring all this magic? And if I go to an API level thinking, and I can go to a Python, I can go to Java language or any of the language and start asking, connect to the chat GPT programmatically, start putting a for loop if statement, call something, and then you can get an output. I can pass it on to a pipeline, it can move off. So it's not that you have to be like a end user to come here. And because we are in the first class, we are doing it from here. You can do it from a lot of places. Okay, so could you say that ChatGPT has got collection of foundation model LLM image? You should think this way. ChatGPT itself is a foundation model. When I tell ChatGPT, it's a client side. The foundation model of OpenAI is called GPT. Okay, GPT has got different versions, 1, 2, 3, 4. Currently, we are on the 5. That is the foundation model, which has been trained with LLM, with image, music, video, code. So you ask anything, it's going to get you. Did I answer your question, MR? There's Francis asking, it's a typing in keyboard, use a piano. If you're using drums, your hands already trained it naturally because you train neuron and fed your brain work. Yes, you're right. Does ChatGPT store the simple information model itself? Searches internet. Okay. Now it will touch GPT. It might also go back, right? And go and check on the internet for more informations. So now you here, you can, the way you are trying to look at these public foundation model is, it's going to really look at internally first. It doesn't know, it can go and look outside, but it's trying to validate with a lot of conditions before it gave you the answer. What are different between versions of GPT? Rakesh, that's going to be a different class. Maybe we can book another 3 hours. That was on the lighter side. Discuss, because I just wrote something about GPT-5 very recently where which itself was a 2 hour kind of a model, because GPT-5 is very interesting because it's giving me a structure to how I should really leverage a foundation model for my purpose. Okay, so that will become an offline topic. So what you can do is you can just go to the, I will not disappoint you if you ask me something. Okay, what are different versions of OpenAI GPT? Okay, if you just put this, so you'll see all the OpenAI model documentation here. So you can go there, and what I would really tell, that you have a lot of information here which you can go and pull here from this particular link, which I'm just sharing it on the chat. You can just go and learn about it. Okay. And once it has the GPT, the client side of it will be your chat GPT and whatever you call. So chat GPT is not a version of a GPT. Imagine, so what are you doing in chat? See, what happens is chat GPT, if you type, okay, it's taking you to this window. So what is this? Anybody can guess. Chat GPT is a client. It is a prompt. It's the UI. So when you write something here, it will go to the server. So what should be the server? It will be the GPT. So the client, imagine previously we used to write your client in your HTML, JavaScript. Okay, now that has become prompt. Okay. The server was your WebLogic server, Apache server, yeah, request and response. Now that has become foundation model. So you type something in the prompt, it goes the FM, it receives the answer. Now, how it actually works is, it will take some time. Hold on. I would love to teach that to all of you today. Okay, if you just give me some time, we will reach that. Now, this is just to visualize you. Now, if I just, instead of this, I can also use other ones. It's not that always I have to use ChatGPT, right? So I can go to another foundation model, which is Gemini. So if I open Gemini, the Google Gemini, now what happens is, again, it's going to just come back and tell you, ask Gemini. Now, if I go here, you will be able to ask what, or let's ask the same questions, so that there is a consistency as you move. There's a reason why I'm using this example, because there was a lot of controversy which got created in one of my project. I'll talk about that as we go. So here, now we are in a different place, right? So we shifted from OpenAI now to the Google Gemini. Now the same concept, right? The client side is your prompt, and the server side, it goes to the, so which is the, what is the foundation model used by Google? So that's, you can see here an example here. You can choose your model here, right? You can choose that I want to use this, I want to use that. You want more reasoning, mathematical model, you can pick up the Pro. Only thing, it'll ask you for a credit card and bill you, and they'll be very happy going for a party. Okay, don't do that. You can use these free foundation models as a beginner to learn about it. And the client side, ask Gemini is the FM. The client side is the prompt side. It's like ChatGPT, you will find that the client side is that, right? So you will see that whatever you're trying to ask, whether it's a Google Gemini or if it is a ChatGPT, it will start answering. What if somebody like a guy who's pretty serious, who comes and tells, I'm asking all these questions in Gemini, OpenAI. I just cannot, I don't want that's such kind of, I want more accurate, fantastic answers, so that it has to be researched so much before I get the answer. Okay. And that is where I'm not going to talk about it. I just want to leave you. There's perplexity. So if you want to try a little bit and know about perplexity, perplexity is built like a search engine within your it's like how they are trying to get more accurate informations from multiple foundation models when you ask a question. So if you ask a question here, it can go to a multiple FM and get you. Now, the reason I am introducing you perplexity is for no reason that you cannot be left not knowing perplexity in today's world. Okay, so let me just put a link. There is no coverage of perplexity, but in a beginner class, it's always good to know what is Perplexity doing in the world of OpenAI. Okay. So today you will see Perplexity is also will try to answer the same question, but now it can go into multiple FMs and get you an answer. They are more well researched. I've used Perplexity for the last 6 months. I find it like it's very refined. If I want to do some my research work, I use Perplexity. If I want to get general purpose informations, I will use ChatGPT client. I will use Gemini. Okay, these are things you'll use. Okay. Now, Perplexity doesn't use one FM. They have a black box which connects to multiple FMs. And Asma, you can actually research it also. That's a very interesting question. It's 100% free for now. That's a very interesting quote. Like everything becomes free. And once you start using, you'll get a bill. So at this point, it looks like you can use it within, if you are in India, Airtel gives you Perplexity to really use it, multiple things. So why am I trying to discuss these topics? Whenever you're talking FM's generative AI as a beginner, okay, you must understand there are multiple options for you. It is not only OpenAI, ChatGPT. You can use Gemini. You can also use Copilot, right? Now, Copilot is another options you have. Now, again, Copilot is from which company? I don't think I have to tell you this. Yes. So if I ask this question here, the same answer. Right? Now, if you ask me, is it all same? Is it different? Right? Now, this is a very difficult question to answer. So as a beginner, you learn as much as possible about different foundation models, but you get into one particular OEM. Maybe you want to get into Microsoft, you want to get into Google, you want to go to Amazon and learn about not simply using it like a user, right? Because today is beginner class, you want to experiment these things one by one. You experiment these four things yourself before you come for the next class. Experiment OpenAI, ask it all the silly questions. Go into Gemini, ask the questions. Understand client is prompt, server is your FM. Client server, right? So understand. Go to WhatsApp, you find the meta. Okay, so each of the OEMs who started this game, OpenAI, ChatGPT. Now everybody is caught on. That is why you see so many versions. Now AWS are different FMs. Think about this. You can be, what is Uber? How many cabs does Uber own? The answer is zero, right? So what does Uber do? It's a aggregator platform, right? So similarly, when you go into a cloud, we are going to cover this up. Don't worry. You go into AWS cloud or any of the cloud, they will provide you options. You can pick the foundation model from them, or you can pick from the other 300 of them. Okay. So you will be given a choice of any foundation model you want to work in the project. So that is where I'd call it as an aggregator. So the cloud provider will provide an FM. They'll also give you a choice that from the console of that, you can also pick other FMs, right? AWS provides that. It provides you more than 300, 400 different FMs you can select using Bedrock as the service. So let's not confuse. At this stage, we only want to know our development in the past was UI, the client side was HTML, JavaScript. Now it has changed to prompt. My server has become foundation models, right? So now we have different solutions for it. ChatGPT is one solution. Second one is Gemini is another solutions. The Copilot is another solutions. There can be plenty of them. Okay, every server, the service provider is going to provide you one. AWS will have different FMs. AWS also allow you to leverage FMs outside. For example, I'll give you a very simple example. If AWS provides you foundation model, which is intrinsic, they provide it from their own factory, which is Amazon's headquarters, which is Titan. But if you feel that I don't want to use Titan, I want to use DeepSeek, but I am an Amazon, I'm an AWS developer or a builder, you can still use DeepSeek also. So it means one, the cloud provider itself gives you choice from their own company, and they also allow you to use different FMs. That's your choice.
Sure.
Is DeepSeek FM? Absolutely yes. So there are so many foundation models. Okay, now if you go to the chat GPT, why to waste time? Can you list me all the foundation models? Okay, now if you ask this question, it lists me these foundation models: GPT series, Claude, Anthropic, Llama, Google, Gemini, IBM, Jurassic. This is under the category called text-based model. So once you read this, then you will not ask any questions. That was on the lighter side because we list a huge. After you read this, you will feel like there are so many of them. Why I have to go and create something? Okay. So there are so many choices. So DeepSeek, which you asked, is also here. It's an innovator. They try to build a small language, smaller model, high performing models, which are useful. Okay, Prashant, does the FM need to be deployed on clouds? How about the organization what does not use cloud but on-premise data centers? Do the other way. You start to be consuming. Now, see, foundation models are available on the cloud for a reason because you need GPU power. You need, why do you want to lock the foundation power? Because you need high processing power. If you are a military networks or defense network, which you don't want to go to the cloud, etc., you have to heavily invest into your on premises and then download the model, and then you can create the compute capacity. Okay, that's also a scenario, rarely used scenario, but it's not impossible to do that. On DeepSeek, I did not get a picture of rainbow to add any config and drop it directly. I'll say beautiful detail for you to imagine the use again. Okay, Rakesh. So you have to do some bit of configurations. We'll talk about that as we go. Every FM behaves this way. If you get into this topic, you will never be able to come out because nobody is able to figure out how many of these models. Now, a simple question of asked, which company, what you're seeing here on the screen is the company name and what foundation model they provide. And then there's a client side. Claude is a foundation model given by the company called Anthropic. GPT 12345 is given by OpenAI. Meta gives Llama. Google gives BERT. Okay, and Google gives DeepMind gives Gemini. Alibaba gives Cuban, like this. So read them, understand them, because this is a great time for you, right? Because now you're not much worried about AWS, GCP, nothing until next Saturday. So go and play. It will take you 3 minutes to download this chat GPT or whatever is intrinsically at the desktop version. You download Gemini, download everything, try out all the combinations, try to understand what they are. If you do that, it will be great. In training your FM, do you use your ETL process, your upload document, or just want to know where your method? There are a lot of topics which have to be covered for us to answer that questions. So if I have to simply tell you, whenever you're training your FM, there is a well-defined process available. There's a data pipeline. In that data pipeline, what is the strategy depends on the project. Yes, you can pick it up from, if it's AWS from S3, you can pick it up from multiple places. You can use a data wrangler strategy, so many things. That's a good question, but reserve it for the future. Hugging Face is a lot of free models. If you choose a free one, how to ensure? See, it's at your, the choice of the foundation model comes with a lot of documentation about how to secure it. Beyond that level, you're responsible for the non-functional side of the security. You cannot go and blame the customers after that. So you get a lot of knowledge. After you get the knowledge, after you understand FM, per deployment, per project, you have to build a complete architectural thinking into the project. So whichever model you're using, they release you the security context paper, etc. use them to look at it. Okay, we have a lot of raise hands. What I would recommend to do is just hold on for a while, because I don't want you to miss some demonstration which I have planned for the day. We will have a separate time for your queries. Don't worry, I'm not trying to encourage it. I'm seeing your queries, but let's move on a little bit. Okay, now let's focus on transformer. No, this is not an easy topic to understand. And I would tell you, if I challenge you, because always we should love challenges. If you are able to understand transformer, you understood generative AI. Okay? So transformer is a neural network architecture. It's like you. It's like a collective, like today 60 people are attending, all the 60 people put together, if they have to answer a question, you can see the power. Now, if the 60 is 60,000, and each of us have maybe some 1 MB of data, 1 terabyte of data, whatever data you know from your memory. You want to combine all this, you can billions of parameters of data together. So what is transformer? Be with me for a while. It's a type of neural network architecture. Okay. Now it is introduced by Google in 2017. So don't forget to read the paper. Attention is all you need. If you don't understand ABCD of that, you're in a good time. Because even I never understood it when I read it first time. But if you read it multiple times, it's like a Kerning and Ritchie C book. It's a small book. People felt this is a very small book. How did it cover C? But it has got treasure in that book. Just 250 pages of treasure. Similarly, if you read The Attention is All You Need, I was talking about Kerning and Ritchie. That was in the 20 years, 2 decades back. We used to have a book for C language, C programming language. A very small book written by the founders of C language, which is called C Handbook by Kerning and Ritchie. So, okay, now people felt it's a very small book. What is it going to cover? It's got treasure. Similarly, yesterday, I think me and Shahid shared a link for Attention is All You Need white paper. That is the basis for transformer. It is the backbone of most of the AI systems today. Okay. Now, to understand this, we have to really get into seeing this in very detail. Thank you, Kaihan, for putting that. Yesterday, we put a link. You have a lot of informations. Now, for your information, I do not want to get too much jargon today into so many things, but it will be a good idea. Before this transformer came, there were some things like RNNs. Okay, there is something called LSTMs. These are terminologies which were used. Okay, now we will not have time to cover this. I just want to use these words in the chat. So if you Google research these words, you will understand like there was something available before transformer, which people found there were a lot of drawbacks. They RNNs and LSTM, you can find that meaning and what it does, because that itself takes a 4 hour to 8 hour to cover. At this point, they always process it sequences word by word. But transformers is the first time where you can process the input in parallel in a mechanism called as attention. Okay, so this is very, very important. Now let's go back and understand this. Here you're asking what is the color of the sky, goes to the encoder, it gets its attention, the decoder tells the color of the sky is blue. This is too much basic to me, but we will try to understand this transformer architecture in detail. Okay, for that I'm going to use a Word document. Be with me and then we'll see a demo. With that, we will go for taking your questions. So let me open the transformer text and we will focus step by step. So can you see this first step? Let me expand it. And I'm going to send this document also to Sahith. Document 1. Anytime, maybe in the course, we are not covering how to create a foundation model. In our first basic class as a value addition, we are touched about how to create a foundation model. use that document to learn before you enter any of the classes. Now we are trying to understand, okay, the transformers in more deep detail. Okay, now the first step in transformer is input representation. Now please understand, you have to be with me. So I will be focusing and helping you understand the first step in any process. It's like when I asked you how many colors in rainbow, you answered it 7. If I'm asking the same question back to ChatGPT or Gemini or to DeepSeek, doesn't matter. All of them use transformers. So first you should understand the text or the data, what you're asking. For example, how many colors or there in each of these words has to get converted into tokens. Now, don't ask me what is tokens. Just hold on for a couple of minutes. Listen to me completely. And then you can just interact with me. So you have to convert, because a human can understand anything, but a system doesn't understand. It's a dumb, it can understand machine learn assembly language, it can understand zeros, ones, it can understand numerical stuff, right? So whatever you're typing in English, it has to be converted, broken into tokens. Okay, and the numbers is what will be created, which will represent the words and subwords. Now, this is very astonishing for you, right? It means like, what is, I'm taking the same example so that you can reiterate. What is the color? If you ask, what will become a numerical representation? Is will become a numerical representation. Every word will become a numerical representation. And then this token is mapped into a vector embedding. Now you might be thinking it's very difficult. What is vector embedding? Nothing difficult. Think about it. Humans can understand English and convert it through the multiple layer, perceptron layer, you answer it. Systems don't understand anything but for mapping it into some numbers and then visualizing it like this is what you asked. Okay, now this is how the GPT got created at the back end. And when you're asking questions, it's answering, right? So this is so important for you to think. So text or data is broken into tokens. It represents words. Each token is mapped to a vector. Now let's visualize this with the demo. So I'm going to close this, and can you see this screen? I just wanted to confirm so that I'm not. Can you see this tokenizer? Just somebody put yes. Okay. Now I'm going to copy this, paste, and give it to you also. You can also try. Now the first step, what we discussed, though ChatGPT itself has given us a tool called tokenizer. Now I'm going to type here what are the colors of. Okay, I just have to change the questions. What I asked you, how many colors are there in rainbow? It's not going to answer this question, okay? It is just going to tell me how it converted this 1, 2, 3, 4, 5, 6, 7, 8 into 8 tokens. And it has got 38 characters. Now, if I come down to this tool and click token IDs, you will see that it has mapped this to 8923199110803553. Now, this is how it works. So don't attempt to understand this completely today. But why did OpenAI give you this? It is for people who want to go and understand. Suppose you attend engineering, or you also wanted to tell a customer, your customer, that, like you've been using ChatGPT, now I'll tell you how it works. So you can take some examples also here. And it is giving you an example when you type it here, how does it really map it, etc. Okay. What happens if it's a typo? We'll come back to it. If it's a typo, it'll ask you now we are not, please understand, we are not learning ChatGPT in the tokenizer. Tokenizer is like, how does a compiler work? So we used to have tools, how the compiler can be seen internally behind the scenes, right? Similarly, tokenizer, when you talk in English, nobody understands. So ChatGPT itself is giving you a tool. What you should do is when you type something, okay, now token ID are not created to data labeling. Data labeling is data. Imagine a foundation model is getting bombarded with lot of information, then it becomes the foundation model. Now you go to the client, you're asking a question in English. So when you're asking that question in English, English is not understood by foundation model. It does some kind of steps. Who does the steps? It is the transformer. What does it do? Step one, it tokenizes. What do you mean by tokenization? It will read your English, convert it into a numerical form, and it will just map it this way. Okay, now it can be a map what you are writing. It can also be what it is. We'll come back to the next step. Let's go back here. It's called input representation. If you manage to do it, people who are 5 years experience in GPT cannot answer this. Now, why are we attempting it? Because if you are able to know this and how to create an FM, you are postgraduate in the subject. Okay, it becomes easy for you to learn tools and services of any of the vendors. No big rocket science. To understand this, you have to be patient. You're trying to understand what's happening while you're using ChatGPT. It's not easy, but it's really, really interesting. Okay, first step in transformer is input representation. Just think that for now. It's converting into tokens, numbers. Token is mapped to a vector embedding. What is vector? We'll see. Now, the second step is called positional encoding. Now, this is very interesting. You typed how many colors in a rainbow. Now, when it maps it to this numbers, it doesn't know which word comes first, which word comes next. So transformer don't process words sequentially. They need extra information about the order of the word, and that is called positional encoding. These are research thinking. So don't feel if you're a little bit lost, not able to understand, it's perfectly okay. Okay. Ultimately, there is an endpoint where you reach from a theory class. These are the ultimate treasure knowledge, right? So you should understand the text is taken, whatever you're typing, draw me a picture of cat, write me a code in Python. Whatever you tell, it has to be broken into tokens, number, then you should understand, then it knows what it is. For example, if you just change, you look like a rainbow. Now here also you're using an English, but now it has to, how does it know what came first, what came second, right? So for that, it uses a concept called positional encoding. If you drag and drop any of these words into Google, you will find a 10-hour of content available. That's not our interest. Draw a baseline in terms of understanding. First, input representation. Second step is positional encoding. It means you just need to know which should come first, which should come second, because when you put a number in the array types, it doesn't know what is followed by the other. Okay. And then there is an attention mechanisms. Now, attention mechanism is basically where it does a concept called self attention. This is the building block of any of your transformers. For this word, sorry for that. Let me clear the screen. So you'll see that the next step is called attention mechanisms. You can take your screenshots. We'll also share this document with you. And if you are not able to understand, you must take time. This is to all the below respect to people who created something. It takes some time. They spent 10 years to learn and build this. We are trying to learn it in 20 minutes. It's not possible. But once you grab this, you're in a superior knowledge wave. Okay, it takes a bit time. Just let me repeat the steps. Don't worry if you don't understand once. It will take some time. First is input representation, which is converting into tokens. Just to know where that word is started, there is positional encoding. The third step is called attention mechanism. Now, if you read that white paper, that white paper's implementation is called a little bit called as a self attentions. So, for example, every word you're typing in chat GPT, for example, if you tell the cat sat on the mat because it was tired, the word it, you can understand because you're talking about cat, refers to cat. The attention will help the model figure that out, like, what do you mean by it? It will find out by using self attentions. So every word, which other words in the sentence are important, is called attention mechanism. Okay. Now, if you want to have a demo of all these steps, right? So one, I had built a tool maybe 1.5 years back. I can't share that because I built one for the customer to make him visualize. But there was an open source tool which I figured out in the morning for all of you. If you want to give a sentence and go through step by step into all these areas, okay, there is a tool for it. I will share the link in a while from now. Before we go there, understand step one is input representation. Step two is positional encoding. Step three is called attention mechanisms. Now, what is this formula we use? We use a formula called Q, which is for query, K for key, V for value. Now, imagine at this point of time, it gets very mathematical. It gets into something called back propagation algorithms. I'm complicating this to tell that engineers in OpenAI 10 years back has to struggle to learn this before they gave you something free. Now you can sit today very coolly and do things very fast. Doesn't mean knowing this is unnecessary. You know it and ignore it. You'll be very solid in the subject. Okay. Scoring like a JSON, but in a different way. It's not that key value pair or something you're talking about. The formula is called query, key, and a value. Let's understand that a little bit. Now, coming back, think about your brain. This brain is called multi-head. So you're not going to have one attentions. The parallel architecture of transformer takes it to multiple parallel heads, and each head can capture different relationships. It means yesterday somebody put there are three things, three layers of perceptron all working together. Okay, this is called multi-head attentions. So we are talking about how a transformer is working. We are looking at behind the hoods, what's happening. So these are the steps. For Gurinder, what we are trying to talk about, so don't worry if you're not fully understanding it. What we are talking about is when I went to Chat GPT and when I typed a simple sentence called how many colors are there in rainbow, how did it give the answer? Okay, that is what we are trying to look at it. Okay, now you can easily go as a user and tell it gave an answer. But if you really want to know how it gave the answer, that is what we're talking about. So don't worry if you're not fully understanding it. I just want to summarize the steps today and you will get this document. You can read them. If you have further doubts, then we will discuss about that also. Don't worry. Okay. Let's go back to the document and see what are the other steps. After it got into tokens, positional encoding, attention mechanisms, and then there is something called multi-head attentions. It means there is something which happens in parallel, like our human brain, the transformer which is running within a system, which is at the back end of the foundation model. So you are triggering your question from your prompt. It goes to the FM. The FM is using a transformer architecture to decode what you're giving as an input. By using these mechanisms, what you're looking at, imagine how it will take one attempt for you to put some sweat to understand this document. Okay. Multi-head attention. And then there is something called feed-forward neuron. Now, this is where our human brain is so smart. If I ask a question, it can work parallel architecture to answer a query. This is called feed-forward neural network back propagation. It's like simulating a human brain. That's how transformer works. So ChatGPT is very easy for an end user. It's very difficult for an engineering person to know how actually it worked. That's what we're trying to decode. Okay, and then after the feed fog, there's something called stack layers called encoder, decoder, and that is how the transformer works. Now, for people who have not understood it, I'll give you a very easy way. There is a tool which is called Transformer Explainer. This is an open source tool. I created one in the past for my client, which I can't share because that was specifically made for training inside. But now for all of us can try this yourself. Okay, now let's see this tool, how you can practice. Now it tells you 20 steps. And I will tell you, if you run this demo before the next class, nobody will ask you any questions in generative AI. That was on the lighter side. Second, when you're attending interviews, this is the most powerful thing you can know in the GenAI. And this is so nicely put for people who cannot understand Word document, PowerPoint. Just go through this. Now, what has this got? It's got some examples, right? So, for example, if I tell to from ChatGPT, if I type data visualization empowers users to and stop and click enter button, ChatGPT will complete the sentence for me. Now these 20 steps will show how did it complete. Similarly, AI is transforming that. If you stop there, so let's take this example. I'm picking up artificial intelligence is transforming. It is putting the word called world. But how did it get the word called world? It's been depicted diagrammatically. So you can see that down, it tells Transformers engine behind today's AI, powering tools like ChatGPT and Gemini. They learn from a lot of text used to write answers. So here you can look at artificial intelligence transforming the. Now here you can see this QKV, whatever you're calling, from the key, query, value. It is splitting this word like this. And then it is trying to bring all these words with a percentage. We'll talk about this as we go deeper into implementing the FMs in this, right? And now there is no reason why it will, what is split, how is it split? There is a lot of terminology for it because the way it looks at is not very logical to the way we think this entire story. The first level of parsing, it takes it very logically in terms of how it looks at it from the grammar perspective internally put. And later it tries to figure it out. It is artificial, it is art, etc. Okay. So if I go to the step 2, you can try it out yourself because the tool is being given to you. It will generate. Okay. It will not work by magic. They build text step by step, asking one question over the what is the most likely next word after this one. So now if I click next, it knows that world is got high priority, but it has got all the other words like the next thing in artificial transforming the way, lives, field, future, workplace. It's put a lot of choice for you. So embedding, what does it do? It turns text into numbers. It transforms the blocks. You're right, Francis. Probabilities. Now, why is this tool very important? Now, the time when the GenAI started, I had been started working on it. I was just figuring out, can I have a tool? We build one. but that was very much proprietary to the client which we deployed. But when you get a tool like this, it's a great opportunity, and you're all starting off your career in this area. Okay, so eat the frog. This might be the most difficult thing to know for anybody in the Gen AI space. If you're able to get 10% of what is being told here, you're good. Don't worry about it. Okay. So here, embedding turns text into numbers. Transformer blocks the mix in, for example, from here, the key value MLP picks up what is MLP. We'll talk about that. And now if you click next, before the transform can understand, first breaks it into tokens. Each token is a list of numbers called an embedding. Each embedding vector looks like a rectangle. You can see a rectangle here, and you can hover to see how big it is. For example, you can see that multiple embeddings are here, and you will be able to click and see that every word has got an ID. It's got a positional encoding. Okay. Now, imagine without these algorithm, you never got the answer called 7. Your brain did a magic, and nobody can explain to me how it did it because you were just telling some history, memory, etc., etc. But from a systemic perspective, there is no magic. It's purely a kind of a algorithmic code. So one, you can go through the deck, you can go through my Word document. The proof of the pudding is in eating. So you can just come here to this demo, run it yourself 5 times at least. You will understand exactly how a transformer works. And if you know how a transformer works, you have cracked the big thing. Okay. So when I click next, there is token embedding which happens. So you will split a sentence into tokens. And GPT-2 has got a list of 50,257. This is an older demo. GPT-5, it's got so many tokens. And each token is matched to a vector with 768 numbers. It does it automatically. And word order matters in language. So you do positional encoding. So every step is explained here as the demo is done. Where does each word come? And after that, there is a transformer block which does multi-head self-attention. Let token share informations and it refines itself. So if you click here, it will just tell you how it transformed the block 1 information, block 2 information. Okay. And then when you go to the next step, which is basically multi-head self-attentions, it let the model decide which other tokens matter for each token. For example, you're given a sentence, it can go singular, it can go parallel, etc., to really learn how the transformer is going to really work. Okay. And then it will token is embedded into 3 new embedding called query. You can see here query. You can see key. You can see value. So if you go to the next step, it will explain to you how each of these steps is done, head 1, head 2. It's so detailed. And I am telling you, this is out of syllabus. I would have just ran a small deck and told class over. Just doing an extra effort for you to give these 2 tools for you to really know what happens in, even if you complete the entire AWS. I got certified in everything. I did not know about this because until when a customer challenged me to tell that, I just want to teach my entire team how exactly the GPT world works. Okay, that's when we build that prototype, which is licensed to the client. But now this is pretty much interesting. Now you should use it. Now, why did you come for this class? You want to learn hands-on, do everything. Interview is a different story. See, once you got the treasure knowledge from here in this demo and you run it multiple times, read some documentation, you suddenly start feeling like when I'm getting into Bedrock, I'm getting into Azure, I really know what is happening. Okay. I cannot explain that what it is at this point. Okay. Multiple heads. Okay. Now I just don't want to go into this. I'm going to just go back to my original deck. What is the time? I leave it to you to read this. We will come back to it. Thank you, Dinesh, for acknowledging it. But at the same time, I just want to ensure that I keep very simplicity. From a deck perspective, what is written? For all of you, when you go through the deck which Sahid has shared, it will have this transformer architecture. For augmenting this, you will have a Word document uploaded. For this, how our foundation model created, you will find one more document. Both these documents would have gone to Sahid. And once Sahid checks it from a internal perspective, you can use these two additional content. After that, the transformer architecture, please use these two links which I have given you, valuable links. Okay. And then you can understand in simple language. So there could be a lot of beginners today. There could be googly running in your head. 50,000 feet above it has gone. That is a good news. Raise the bar of your learning, right? So you want to be special people at the end of the class. Okay. So when you go for somebody and somebody asks how exactly a transformer works, you should run to a whiteboard. Interview is over. Okay. Because anybody can come and explain how to type in chat GPT and etc. But very rarely somebody can understand what I'm telling in the last 20 minutes. And I have made in my previous workshops, every student of mine go through that demo 3-4 times. The level of questions you will have after that will be lesser, because most of the questions comes because you don't know exactly how it works. So now let's summarize this. Thank you all for your compliments. It helps me to work more harder. How the processing happens: tokenization, encoding, word embedding, decoding, and output. This is a very simple review. Okay. I don't want to make life very simple for you. Right. So you can also read. And for your information, there is something which is also there in the portal, in the e-learning portal, about this particular concept of transformer. You can read that also. Anyway, this video is also recorded. You can watch it once more so that you can get all this information. So the more you know about transformer, what is AI, what is ML, what is deep learning, what is generative AI, what are the different use cases for all of these, what is foundation model, okay, what is transformer? Can I do a thesis about transformer? Please don't do that, but you can learn about it as much as possible. How do I smartly learn? I've given you the way. Because if you go and read the white paper and all, it will go above your heads. Now, if any point of time you go and ask your colleague, you are typing in ChatGPT, do you know how it worked? And you try to explain it to him once through this learning, you will also learn. It's not easy to articulate this to anybody. This is the most toughest topic to help. There are two tough topics in this area. One is how to create a foundation model. For beginners, you should know that first. Second, you should know how a transformer works. If you know these two, you have covered the two difficult topics of the subject. Okay. Now let's go to the quiz. What is foundation model? There's no wrong answers because all of you have become solid people. So answer is B. A model that is pre-trained on large corpus of data, fine-tuned for various downstream tasks. Okay. So please use these two documents. If you have not understood the foundation model creation to the depth, use that first Word document. Second, about transformers, go through the second document, see the demos. The course by itself gives you a PPT, which is also really solid. Combine these two things, it will be really good to go. So what we do now is, because this is the only foundation class we have, and then we get into the track, let's first complete what is pending for the day. We have, and then we will go back to some demonstration which I promised. So a quick journey now. You all have been given a lot of knowledge now on what is AI, ML, deep learning, generative AI, some bits of how a foundation model looks like, various foundation models. You have seen several foundation models. We understood transformers. how a transformer works. There's documentation given to you. Please download and use it. We have reached that level. Now, some consideration you must do, irrespective of which cloud you're using, is uh, fairness and privacy. Okay, now what you mean by this is these words, what you see here, like toxicity, hallucination, intellectual property, plagiarism, disruption of work. Now, why is this covered as a beginner? As you're thinking like it looks really fancy, it looks very cool, it looks exciting, but nothing is exciting for an enterprise deployment because they want something to run always without any trouble. So, you must study as a beginner a little bit of text about responsible AI, little bit text about understanding what are some of the concerns which we have in generative AI. The solution for that will we will learn it through the tools which has been provided by generic vendors, or somebody like an Azure provides you a set of tools how you can manage toxicity, hallucination. AWS provides you a set of tools. uh, your GCP provides you tools. As your implementer, you will learn those tools. But as a generic understanding of this is very important. What is hallucination? Suppose you ask the chat GPT about you're sitting in a car and you're trying to do some kind of communication. Now, first of all, let's understand hallucination. I'm just taking one example, hallucination. Hallucination is a word which sprouted out of a neuro disorder. For example, if you look at schizophrenia, a disease, now people can visualize or they can hear sounds. So it's a kind of a mental illness where people are able to see virtually things which a normal human being don't see. In the world of generative AI, you might ask something, it might mean something. So you might find that your data is getting a little bit different. So we will talk about every example of these things when we get into a solid module on security, privacy, okay, responsible AI, which is part of the course. Okay, but ultimately, why is then this slide available as a beginner? This topic can be read as a blueprint also. So you can go and learn about these concerns and everything from a white paper researcher. Okay, now keep it at that level. I just want to leave this slide. Uh, yes, watching the movie Beautiful Mind is fantastic to understand hallucination. And same thing happens in foundation models. So last time when I was trying to ask it something, you sometimes get angry with the chat GPT because I'm asking something, it's giving something, then you're asking something, something like that. Okay. So this is just a slide for you to live and think, and we can cover this in detail as we go. Okay, now we'll just get into, because these are things we have seen and we just covered this part, which is tokenization, which is very important. We understood what is tokenization. It's well also explained in this slide what tokenization does. It takes the original text, divides it into different tokens, and then it converts that into a different token IDs. Okay, now you must be a master of this at this point. But this is a very simple slide to really break down what we covered from a word level tokenization to subword tokenization to character level tokenizations. Okay, this is how it is working. Now, embedding happens. We'll come back to what is Sakshi on embedding. First, let's get this tokenization right. And what happens here is you can take an input, basically like have the bar so preceded. You can break that into different tokens. Then you convert the tokens into a numerical representation. That's called embedding. Okay. Now this embedding is done practically. So you must know how to do this. For example, you do vector embeddings in when you implement RAG, you will be using a lot of embedding models. We will be using vector database, etc. But internally, this is how it works. Input to tokens to embeddings, right? Now this is the step-by-step process. Token is nothing but pointers. Now, pointers, because the way it is shown here, you might interpret it that way. But to me, if I was an implementer at the deep implementer of how from a product development of the chat GPT, I will be thinking that like it is a kind of an algorithm. It's a kind of a mathematical way by which I will be able to break the big sentence into multiple numerical representation and then map that into a place where I can read those representations and then back propagate it one by one. Okay, so tokenization is very important. And then you have transformers, which is the deep learning architecture where it looks at. We already have seen this in detail. You can read this slide. Let's take an example. A lot of you, if you're confused, you're on the right track. If you're very clear, it means something has been told in a very simple way to you about these big topics, which is not the objective. We are here to get the best A's job, best certification, best knowledge. The more complex you learn, the better for you. Okay. How the transformer model works. So let's take an input so that we can try to summarize what we learned in a hard way, in a simple way. So if you type puppy is a dog, as a kitten is to dash, from a chat GPT UX to the GPT model, now you can answer it, but how did it write the answer as puppy? Let's figure it out. Okay. So what happens is it will first, how a transform model completes a sentence is what we are looking at. It will do tokenization and encoding. It will do word embedding. It will do decoding, and then only you will get the output. So this is the step-by-step way by which it will do and complete that sentence. So for example, if you look at the sentences, each of the word from the a puppy is to dog as kitten is to, each of them will be mapped into some kind of a numerical value. Now, what is this numerical value? By the time the ChatGPT was created, it knows about a lot of English sentence. It knows about all these different words which is coming to it randomly. So it has got all the inputs. So by reading that, it really got, thank you, Vigo, for sharing that. It will be able to read all these sentence and then relate it to. Now, if you really see, A has got 1037, dog has got 3899. If you really look at like certain things will be very close. So nearest neighbor algorithms and all this stuff. So you will see that dog and kitten are little more closer compared to something which is far away. It can detect all these things only by numerically looking at things. Okay, so first step is to pick every word and then try to put a mapping like this. After that, it does word embedding. It tries to map it into a vector model and then look at like what are the different words which are similar meanings are located to close to each other. So one of the rules of the thumb where you try to implement this is if similar meaning words will be located close from a numerical representation. So it will be able to draw the word embedding. Since this slide deck is available for you, I think the link is also being shared by Sahid. You can download it and read this. You will understand it, but go deeper with the resources we are given additionally so that you can combine the knowledge so that if you're a beginner, you can just go through this and then go there. If you're an advanced person, you can skip this and try to experiment more. So when you get puppy is a dog, as kitten is to dash, now it will have a choice that cat is coming 9.2, bird is coming 5.5, beer 4.7, human 3.7. So by even when a machine works, it cannot really differentiate like a human, but it has got a weightage. The cat has got 9.2. Now that is how it gives puppy is a dog as kitten is to cat. Now this is unbelievable for people who are reading it because we might misunderstand actually that a machine actually understood the way the human understood. But what a machine does is very different. It just pulls this particular text, okay, it just puts it into a tokenized vector, then it word embeds it, and finally it puts weightage, and that is how it answers that it is a cat. Okay, so please understand this is a very important slide deck which you must go through as you get time. So let's look at a quiz. All of you are intact and also understand generating new is very, very important. Okay, so the answer is very correct, absolutely on bang. You always generate new content with your generative AI. Let's look at one more question. Now, there is a pattern which Rakesh has seen. This is on the lighter side, and all the question has got answer as B. So I will tell Sahid to change the question that the answer is changing from the next class. That was on the lighter side, but answer is B. Let's look at, see whether this is also the same. So you don't have to read the question now as a chat GPT or a intelligent machine. You can go and click B, right? Here also the answer is B. So we have covered some topics. Now imagine we are at the basic class yesterday and today. Okay, so we have understood a lot of things. Not at the base level, we have raised the bar to think big, but at the same time, we are at the foundational level. One last topic before we want to stop because we want to complete what is to be covered these 2 days about prompt engineering. So you also need to know difference between prompt and prompt engineering. I want you to take 20 years backwards of your career. I want to take my career 20 years backwards. If I was developing any systems, I will have a client and I used to write COBOL programming 24 years back, where client server, everything used to be one file. We used to start our program from the eighth line, the rules of thumbs. It will generate a file called dat file, which is the database. So COBOL used to be the first language I wrote. Then it was C, C++, Java, where we had a client server, right? The client used to be your Java code or your, what we call it as swing architecture, whatever is it. And then there's a server, client server architecture. Then we have the three-tier architecture. Then we had entire architecture. Then the cloud came. All these innovations and change were not big deals. But for foundation model, when it came, it is changing the way we entirely look at things. Because the client has become prompts. The server is the foundation model. Now you have to play with these two. This is what you're trying to do in this world of generative AI. That's the client is called prompts. Now, if you type whatever comes in your mind in English, this is again on the lighter side, that is called prompts. If you want to learn the art of prompting, that is called prompts engineering. Because you can type whatever you want, but if you don't ask the right questions, you don't get the right answers. So the question is there a way by which we can learn how to write the right queries? That is called prompt engineering. So I want to leave some resources here apart from what we have put together in the portal so that you can start there as a foundation guide. So there is a prompt engineering. Let me pick that guide. Okay. Now, when I read prompt engineering, when I try to really look at learning prompt engineering and develop my maybe a couple of years back, this is the resource I used. Now, there is a really important reason why I would recommend this because they are not for anything specific to any of the language because you are come here to learn multi-cloud. So if you want to learn prompt and prompt engineering, you learn it through this guide. Start this. You have 5 days time. Just browse through this. This is generic. But once you get into AWS, you might learn prompt engineering for this model, prompt engineering for Titan model. It can be very specific to a specific model given by a vendor, etc., etc. But if you want to create a benchmarking, blueprinting of learning prompt engineering, this is a fantastic guide because it's going to talk about different techniques. It's impossible for any course to cover because I had done some 40 hours, 50 hours program just for prompt engineering. It's so big topic. It's not required for you to know so many things. The only thing you need to do is to read this guide a little bit because it's going to talk about everything what is required for you. And even if you can read 5% of this link, it's good enough for you as a beginner. And once you complete this, you should go to chat GPT, you should go here and there and type whatever you feel and see whether your answer is coming right, where you're going wrong. Okay, this is a very scientific way of learning this subject, because there's a natural way you write, and then there is a rehearsed way you can learn. Now let's talk about what are those rehearsed way, and that is exactly what is called prompt engineering, more from a easier perspective, because we don't want to complicate this topic today, because we are just starting off in this topic. So prompt engineering, what do you mean? It's a process of designing, refining input prompt to guide AI models or LLM to generate desired output. Imagine you hire a lateral hire person in your company. He's come with 20 years of experience in SAP. Okay. And you have hired him. And that guy is loaded with SAP knowledge. Okay. Now, if you go and ask what is SAP to him, he might slap you, because he will feel that you are such a person who don't even know how to ask the question, right? So but you must have a level to talk to him. So what can you talk to him? You can tell like, you're an expert, but our company works this way, these are our projects, this is how we do SAP, we want your inputs, and start asking questions. How do you think we can better it off, best practice? No, that is prompt engineering. So if you ask whatever to the chat GPT, it will answer, because it's a machine. Human, you cannot do that. If you ask silly questions, they will get totally off, right? So prompt engineering is a practice of designing and refining input prompts to get most accurate. So let's take some examples. But before that, these are the parts. You give instructions, context, input data, output indicator, right? So this is an example of a prompt engineering. What you're trying to do is write a summary of a service reviewing using two sentences. You tell, so you give that there is a paragraph here you're trying to look at, and you're giving an example like an instruction is given to the prompt. There's a context you're telling, like you can look at online and shipping, and then you give an input data. It is taking these three inputs and giving you an output. Now, this is basically you're rehearsing yourself. Now, imagine you want to write codes in Java, Python. One way is you write the way you want. So once you go for testing, somebody might tell you're not optimized for memory, optimized for this. You must learn a code engineering practice. You start getting into multiple blueprint, reverse engineering your writing, and then you learn how to do that better. Similar to that, initially, I would recommend you have a free will. Okay, go and type whatever you want. Learn that in a hard way, that if you just ask whatever you want, it's not going to get you the right output. So you must try to prepare yourself to understand prompt engineering, and so that it can help you to get the right output from the foundation models. So this is just simply academic way of understanding that these are different parts of the prompt engineer. So this is called a prompt, like input that give the model to generate a response. Okay, for example, you can tell translate the following text from English to Spanish. How are you today? You can get an output. Okay. Is assigning it persona part of prompt engineering? No, that's a little bit different. We'll talk about it, Hamad. That's slightly different from prompt engineering. So what prompt engineering is going to do is, it is like, imagine, I'll give you the example of a lateral hire now, that you hired somebody as a lateral hire. Initially, what will you do when you hire somebody? If it's an experienced person, you will only talk about your company, your projects, and tell them like how you're going to align to myself, right? So what do you do to that person? You ask questions, both sides. So prompt engineering is like fine tuning the foundation model like a lateral hire with asking several questions, so that you're able to improve the foundation models. What if the lateral hire is not improving? What you will do is you will give a Wikipedia of the company, you will share all the project documents and tell them, please refer these documents and we'll meet again. That is called RAG. Okay, so the same way you started with the dialogue of asking questions, asking questions, asking answer. The person is building his knowledge, building his knowledge. That is called prompt engineering. Second is you gave some documents which is apart from what he knows. He's able to embed those documents into his head, but he tries to put that inside as his knowledge. That is called as RAG, which is retrieval augmented generation, where you're trying to give him supportive documents. What if he is not still picking up the lateral hire? You will put him into a training. You will tell, come 1 month into our on-site, we will train you 1 month. So that's called, you can pre-train with new data, etc. to fine tune. What happens if he's still not picking up? Send him off. That was on the lighter side. You might create and you might rehire somebody, or you might create somebody internally and tell that let him transfer. So that's called creating the foundation model. So you will try all possible things. When you are prompting, you don't get the answer, you can do prompt engineering, you can do RAG, then you can do fine tuning. One by one, you will do the steps until the model become very accurate. It is an ongoing, continuous process. Nothing is that you will be able to change. So prompt engineering, retrieval augment generation, fine tuning are all part and parcel of the process to fine tune the model, because you get a raw model out of the factory. You want to make that model closer to the customer, right? For that, you do a lot of work that is called, these are different techniques to use. Prompt engineering is one technique, RAG is a different technique, fine tuning is a domain specific training is a something. We'll talk about all these things from an implementation perspective as we reach the higher classes. So what is the difference between prompt engineering versus fine tuning? Okay, now this is very interesting, most important question which people don't understand. So imagine like what Prabin is telling, asking a question to pre-train. Now you want to create a foundation model. Imagine Prabin wants to create a foundation model. So he got all the data, okay, and then he cleans the data, the pre-processing stage, and then he started actually training that model, and he's created the foundation model, which he calls as Prabin. Okay, so imagine that model itself is called as Prabin. It's been released to the market. Now there is a client who's testing this model and saying that it's hallucinating, it's not giving the right answer. So as and when you don't get that, you will start with prompt engineering as a way to ask questions, and then you might give additional documents to train it. Now in both these steps in prompt engineering, whatever Prabin has created in the factory, you don't write inside the foundation models. Imagine when you create a foundation model, you create lot of billions of parameters of data. It is mathematically written inside with something called weights. It has got some numbers attached to it. It's a very scientific process that it gets created. So in prompt engineering, you don't touch inside the model. You will surround that model with some inputs and data, so that when you ask a question, first it will check within the model. If it is not there, it will go and check outside the model with this, and then it will respond back. So prompt engineering, the weights attempts to guide the trained FM, but in fine tunings, you will take a new data and then you want to rewrite that the weights inside the foundation model. It's a more tedious process, fine tuning. So what you do when you get a project is, if you take a raw FM, you give a client and see whether it works. It works, your job is over. Doesn't work, you will start with prompt engineering. It doesn't work, you will do RAG, because RAG and prompt engineering doesn't write on to the FM. Okay, it's only that you surround it with some data so that it can, for example, let's give an example. Suppose you ask a question to the foundation model, what is the leave policy of a company X? Okay, so what the foundation model will return is telling, like, I know what a leave policy in general, but I don't know the leave policy of your company, right? So you don't want to write then you go to the HR and tell, give me your leave policy, and then you receive that in an Excel sheet or a Word document. What you will do is you will keep the foundation model intact and surround this Word document on the top of the foundation model. It will be embedded into it. So when you ask a question, because FMs doesn't require to write this Word document, you'll go to the Word document, fetch the answer, and give it to you. So that is called as RAG. In prompt engineering, you can ask some questions to fine tune the FM a little bit to get the answers. These are different techniques you will use. Okay. So fine tuning is a very complex process, and lot of you have been asking this in the chat. How do I fine tune the model? It's very practical to doing fine tuning once you reach projects in foundation models which are pretty much more enterprise ready. You might have to take customer data, put it onto a VPC, put it onto a secure networks. Customer data cannot be shared, confidentiality has to be done. It takes time before you actually fine tune and get an output. So, in other words, fine tuning is achieved prompt engineering rack? No, the way I would want you to think is you get a raw foundation model. Now, there are multiple ways to really give more information to the to fine tune to make your foundation model better. One of the first way is prompt engineering. If that is not successful, you might go to RAG. If that is not successful, you might do fine tuning. And then you might finally go and tell that none of them is suiting. Maybe I'll change the foundation model or I want to create my foundation model. These are different techniques. Okay. Fine tuning is almost retraining the model. That is right to tell. But these are different techniques. So I think about an example I gave you on lateral hire. You tried first to ask questions to him to fine tune him. That did not work. Then you started trying to give him some documentation. That is RAG. That also did not work. Then you put him into a room and started giving a lot of new inputs and data to make him capable for the project. That is like a fine tuning, which is more tedious. Step by step, you will be able to do. Okay. So these are some of the best practices of prompt engineering. Be clear, include text. I don't believe in all these statements. The best way to learn prompt engineering is to do it. Okay. Now, no course, to my knowledge, can cover this entire engineering practice of prompt engineering. So refer the promptingguide.ai. That is an exhaustive document. And I will tell you, even if you know 10% of it, it's good enough. Okay. Now, let's look at some types of prompting. So, unless you use jargons in the IT industry, you will not be called intelligent. That is not a lighter side. So, once we use words like zero shot, few shot, you suddenly feel that you're learning something new. They're quite simple things. Don't complicate. We will take some examples of each one of them. The first type of prompt engineering technique is called zero shot prompting. Take the word called zero. What do you mean by zero? You are making a ego of a foundation model. So what you're telling a prompt is, you ask me a question, I will answer. Today, all the foundation model, which are very powerful, doesn't need any examples. You ask a question, it will answer. Okay. So what that means to all of you is, in the olden times, when I tell olden times in generative AI, there is no olden times. I'm just talking 1 year back. If I go and ask a question, what is the most broad products in Amazon.com? Something like that I ask. It will just give me some generic answer. So I might go and tell what are the products, please refer this e-commerce site, please refer this customer. If I give some examples for it to really think, it gave me a better answer. So zero shot prompting is you ask the question and stop. Okay. When the task is very clear, for example, translate this sentence into Spanish. The cat is sleeping. You don't need to give an example for the foundation model. So zero shot prompting is to generate a response where you don't give any examples while you're typing. Okay. In few shot, as the name suggests, you might give some examples as you give a question so that the prompt knows what is the context of your question. That's called few shot prompting. Somebody, I remember 3 months back when I was doing a customer workshop, customer told if somebody has a common sense, he will know how to when to do zero shot, when to few. He is absolutely right. You can either read these jargons and then learn. Other way is you are a freelance, you are a very evangelist kind of a person who goes to chat GPT, asks this question, it doesn't answer, okay, I will ask it this way, I will ask it that way. You are actually moving between all this prompting technique without knowing these are the names. I don't recommend that because we are all want to get into a job and everything. You must know zero shot prompting is prompting without any examples giving. So you might go to a very modern foundation models which can answer without you asking anything specific. In few short, you give some examples. There is other techniques like chain of thought. tree of thoughts. We are going to take examples of this when we go into specific areas where you implement these things. But at this point, as a beginner, you must know these are different techniques. In chain of thought, it is like a language model, like a something like you can ask one question of the prompt and then you can generate the next question, something like that. You can combine a chain of thought, and even chain of thoughts can have be of type of zero shot and few shot. Then there's a tree of thoughts. Like now, what are these things? Basically, when your projects are becoming bigger and bigger, the prompt engineer is a job role available in the job sites. So you must understand why the prompting guide I put it as a link is because you can take it very casually that everybody knows ChatGPT, they're typing something, getting the output. They use Perplexity to get more refined output. That's one way to think. But what is something which any foundation model is dumb is it doesn't understand customer. Okay, it doesn't understand the use case because you are meeting the customer. Now you the right questions what you ask matters. So today in the world of vibe coding where everything can be generated, it means you should know what to ask it. If you don't know what to ask, then you will be not be able to leverage these models. But fortunately, there is this models which are basically are becoming very smarter. Well, you ask a question, suppose I am a dumb person. I ask something question, it was prompting me. Are you meaning that? Are you meaning that? And taking me to the question also. So that is also possible today. But these are traditional four types of examples you can think about. I would not recommend that you should go and master all these things at this point, but learn them as a beginner. Now, somebody has mentioned LangChain. I think Francis was mentioning. As a beginner, you must understand what is LangChain. Okay? It's because let me just take you to the LangChain website. Thank you for bringing that. This is another beginner topic. Now, what is LangChain? So, best thing is to go to their website and see what it is. But let me explain it to you in very simple words. What is LangChain trying to achieve? Imagine when we build our Java program or Python program, even if you're not a builder, imagine your team was building something. Initially, we used to write the code in Notepad, okay, and then we compile. And then we had a concept called IDE, Integrated Development Environment. We had different tools which we use to really build the code. And then there is a concept called frameworks which came in, right? Struts framework, Spring framework, Hibernate framework. Now, if you really imagine what these frameworks did was basically it used the MVC architecture, model, view, controller, where you can easily write these codes and be able to split them into different layers so that the frameworks helps you to build codes faster, right? Now, in the world of generative AI, when OpenAI was in making, okay, when ChatGPT was in making, because let's not talk about any other, nothing was available 3.5 years back, but for OpenAI, right, on this space. When they were building, LangChain was a startup company, okay, which was doing some activity around the same domain, but they were thinking from how do I create a framework. Suppose you have a model and you are writing a client, how do I persist the queries? Okay. How do I do chaining? How do I do agentic? They were thinking it ahead of time. Now, you know about startups history, right time, right place. So LangChain became so famous. Now Bedrock will integrate with LangChain. Azure will integrate with LangChain. GCP will integrate with LangChain. But what is LangChain? It is nothing but a framework given to you. So while you're building code from client side prompt, server side foundation model, you go into a framework, start writing the code. You want to automate a lot of things like chaining, you want to automate persistence, you want to automate things like language graph, what Francis is telling. So you can use a LangChain. So LangChain provides you a lot of these products like which is called Graph, Chain, Smith. Now, this product you'll have to integrate. Now, what happens with the OEM. This I'm going to tell you a true story, no beating around the bush. The earlier catch up was with OpenAI, LangChain. But once it came to OEM like AWS, GCP, Azure, they never had such products, right? So later they had a strategy to bring their own services on generative AI. Then they started thinking how I don't have something like LangChain. They start integrating with LangChain. So now you will have two options. One is there will be some intrinsic tool. For example, AWS provides something called agents, which you can also simulate what LangChain is doing. But LangChain is also provided because a lot of customers have already started using LangChain, LangGraph, and all these are frameworks. There are platforms which is called LangGraph platform, LangSmith platform. When you go to resources, I want you to interestingly search for LangChain and Bedrock. Just to give you an example. So it will just tell you how they both work together. Okay, it means you can combine these two together, but they have no combination. But later, when Bedrock came in, they told we will work with LangChain. So there is an API linked to it. So ultimately, as a builder, you can bring these pieces together by using a concept called integrating this through a framework. Now, why is LangChain used? It's no big rocket science. If you know Struts framework, Spring framework, why did they come? You're facilitating a developer or a builder to do things faster, persist better, etc. That's the reason that we have LangChain. Thanks, Francis, to bring that. Let's see any more slides left, and then we will go back to the demo and take questions. These are different prompting techniques. If you want to learn prompting techniques, okay, what is LangChain? Let me repeat once more. Suppose you're building an application for your customer, okay, on generative AI. So your client side will be prompts, your server side will be that you pick up any of the foundation models, and then maybe you are packaging this into an application code and releasing it. But now, Gurinder, what can happen is when you're building these applications, you need to have a lot of this plumbing service as a builder. For example, you need logging, you need persistence, like when you ask a query, remembering the previous query, caching. Now, these things you have to implement if you don't have a LangChain as a builder in Python and Java. So LangChain give you ready-made templates by which you can speeden up the process of your entire project because it's a framework given to you. So once you have a framework, you can build applications faster on the generative AI. So LangChain was the first one to build these frameworks because they were there when the OpenAI was doing their research. They were another startup company which were building the framework on the similar lines. When this became up, they became famous. So to put it simple, if you are a person who is on generative AI, who's building something, you will might be using some frameworks like LangChain or LangGraph to build that. Is it like Visual Studio where you can package the code? Visual Studio might still be useful for you to develop your line of code for generative AI, but LangChain now can be integrated into the Visual Studio. Maybe you can tell that I want to plug in the LangChain as a framework into Visual Studio. So while you're writing your code, you could still use it. Who are the competitors of LangChain? Let's go and ask ChatGPT. So let's use that. Who are the competitors of LangChain? Okay, so let's see what it tells. Now there's fine tunings like extending the FM. You're right. Extending the FM could be thought about like you're taking the FM, making it appropriate for your project or a use case. Will be a nice way to think about. So there are some multi-agent agentic frameworks. These are the competitors: AutoGen, Microsoft, Crew AI, Super AGI. So you have a lot of different dedicated these frameworks. You can have a look at it yourself. I'm not going to really give you this. So ChatGPT is 10 times smarter than me for sure. So that is the reason I did not wanted to answer this. I just put it there. These are questions you get better answers because they're far more 50 times or 550x times powerful than me because they have all the data, right? So you can really go there and pick it up. Where LangChain sits in the AI block diagram. So once we start our class in the specific service, uh, we will try to look at it in terms of like based on the AWS stacks, but LangChain should sit in the development framework, right? Because so where does, let's put this question, where does LangChain, does it sit in the AI framework? And we'll tell it to generate. Let's make this as a slave for me, right? Now, why I should think. It will talk about foundation model, which is basically your LLMs. Then there is a hosting. So the orchestration framework is where the LangChain will sit. Okay. And then application layers and the asking your questions for ML ops and etc. It doesn't actually do the ML ops stuff. It's been done with a different framework, but ultimately your answer of asking where does it fit, it is in the orchestration framework. There are a lot more things Vigo is giving. Go for it, learn. And ultimately, I just wanted you to know the word called LangChain because I'm sure there'll be some lab for you to do on LangChain. You will learn more. There are things like something which can go wrong while you're doing good. Suppose you go to a war country, okay? Suppose there's a war happening in some city, and you are trying to ask how do you hijack this particular place, etc. You will be in the jail for sure. Somebody who created the foundation model should write when you ask that questions, it is illegal to ask this question in this particular region, right? So while you're doing prompting, sometimes it can get into terrible problems, right? So it happened a year back. Now people are very smart. If you ask questions, they play very safe like humans. If you don't know the answer, I will get back to you. These are very standard answers. I will ask it later, something like that. No, no, even the foundation model is smart enough. It's thinking and telling now that I'm not supposed to do this. But our guys have got this peculiar technique of going and doing things by which you can fool around the foundation models. Okay. Those are all techniques called prompt injections by which you can influence the output of models. Now, there are a lot of examples for it. Currently, this is not the class to cover these things, but you must understand there's something called adversarial prompting. It means you can do, there is a hacker, there is a programmer. The difference, you know, programmer is building a code for the customer use case. Hacker is also an intelligent human who wants to do it in the opposite side. It's also a useful resource to hack the system. So you will find that the prompt leaking is injections or techniques which you should handle while you're doing the client side. Now, how do you generally don't go to ChatGPT and type for your project. So you might be calling these prompts through your code or through your frameworks which are available where you can instantiate any of the foundation model programmatically and then start writing, do this, do that, etc., etc. But while you do it, you have to take care of the injections, leaking, all these are prompt to happen. Injection is a type of attack where malicious user can manipulate a model by crafting special prompts, okay, and it can really take that into a very difficult job. So this is not sessions to cover this, but imagine there are things like guardrails which have been put across. There are ways by which you can really stop these things. That is what is more interesting, but you must be aware as a beginner such things can happen. Let's look at some quiz. What is the primary goal of prompt engineering in AI? Now, you can go by the rules of thumb. The answer will be, this is on the lighter side. Hopefully, we will work on next quiz onwards. That the answer is not B. Okay. What are the following is a key principle. Now let's break the rule of thumb, which we all have told like always the answer is B. Which of the following is a key principle of effective prompt engineering? Okay, good. We have seen an answer which is different and all of you are intact. So what we do is, I think we have reached the end of the PowerPoint. Anyway, the PowerPoint is shared. I leave it like this. Now what we do is, we do something different now. Okay, we're going to try something before we wrap up for the day. Okay, now imagine, let me just give me a second. I'm going to type Visual Studio Code, right? So for people who are not builders, developers, my intent is not to teach you coding. My intent is not to teach you anything like, no, you should be a developer, nothing. Imagine today everybody is talking about prompting for coding. Now let's go one step ahead and tell we can prompt to build the website itself within minutes and seconds, right? So up to this, we have been talking creative stuff like talk about generating this, generating an image, generating that. That is one part of the story. Serious stuff happens when the productivity gains can be very high. So what I'm going to do here is I'm going to call. So you can see that I'm using GPT 4.1. And in GPT 4.1, I'm in Visual Studio Code. You can be in any of the IDE. And I want to create applications, okay, with the chat GPT by trying a prompting. Okay, this time I don't want to write like what is the holiday in that, etc. But I want to do some serious stuff. So I'm going to type create for example, a Python. You can type whatever you want. I'm just trying to pick something which I did recently, web app, okay, with the home page that says, welcome all of you to the K21 generated app. Just I'm giving some name. So I'm going to just tell create a Python Flask web app with a home page that says welcome all, and let's click next. Now what it is trying to do is I am actually writing the. Now what is Flask for people who don't know that? That's not of much importance here. I am trying to generate a code out of prompting. That's the interest here. So I tell create workspace, right? And then I create a new folder here, which I call it my name. Let me put and I'll create and I'll select this as a parent folder. Now what happens here is, let's see that how fast it can generate code for me. And once it generates the code, I can open it. So once I open it, you can see that you will find that the entire code is being generated out of the context here. I can run it and run it. So let me do one thing here. I made a mistake of not trying to add something, the library. So I'm going to repeat these steps very fast so that you can see this. So go here, Visual Studio Code. Now you also get the flow. You can install. I'm going to go to the Chat GPT here, which is basically here. Sign in if you want. Let me close this. Okay. Let me share my screen once more. And now I'm going to open. I think the sharing is not successful. Let me share this desktop. Okay, cool. You can see the desktop. Just give me a second. Let me exit this, close the window, share. Okay, can now see your screen. It tells me. Now let me go back to the Visual Studio Code. I hit here and I want to add and paste this particular context. I'll remove the dot and click next. Create workspace. Okay, it's generating some code for me. I open this. Something going wrong here. I just wanted to. Okay, the dots is a problem maybe. Python web application, etc. You're right, absolutely right. It must take hardly 2 minutes for me to really finish this. I'm not sure why it is taking so much time. Okay, here is a py file. I compile this file and it tells me just to go to the browser and run this particular app. Okay, now what I'm going to do is to go here to here and type this. It tells welcome to my first AI generated app. Now you may not know really though the power. This is a working site you can create. It took a little bit time for me, but it could take maybe 30 seconds for me to generate an applications out of the Visual Studio Code where I have my app here like templates. I have the index file which tells my first generated app. This is my Python file which I'm really looking at. So I don't stop here. I will go here and tell if I want to add. So imagine this is basically called as uh, building your code on the fly, like with a vibe coding by using this as a primary way. Now, if I just paste that, you add a bootstrap to this and inside a button, click me and do this. Okay, I will remove the pasted image and I'll click. What it does is it picks up the existing code and then it started generating an index HTML file with the button what is required. Now there is an option here for me to tell that just add this into the HTML file, and you have an option to tell that you want to edit it and change it, or you can tell keep. And once you keep it, it has added a button to this. You can go here. If you just refresh it, now it has got something like a button. When I click me, it tells hello from Copilot. I don't stop here. I can just go to the Visual Studio. Suppose I want to create a to-do app out of it within a minute or so. So I can still use my Visual Studio Code here, and I just go back here to my place, and then I can tell that I want to go to the step 3. Maybe I wanted to create a text box to add task like a to-do list. So I come here and tell I want to paste this. Okay, I remove the dots, I remove the pasted image and click next. Now it will generate me a mini app like a task manager, and it will tell me that I'm going to give you a py file, which is a Python file, which you should update. I'll also give you an HTML file, which you can update. How do you update it? You can actually go and tell that I wanted to update this particular file by trying to click each of these buttons. So you can add a context to this particular file. So for example, I can add this to my Python code and tell keep. Coming down, I can select this, add the HTML file, which is also generated into the HTML file, and then I can tell keep. Now, if I want to understand any of this code, I can just select that code line and tell explain to me, etc. That's all possible. When I come here and click, if all is going well, it has created a to-do app. Now I can tell that first exercise in the morning, add task, and then check code. Now this, what are you using? This is vibe coding, where I just get, basically, you can write a boiler Flask code manually. Copilot will do that in 2 seconds, and then you can build a front end, a back end together without writing a single line of code. For people who are asking, should I need learn coding? You can write English statements, but you should know what to write. You can hire a good developer. Then if you can build a mini app, which might take 3 hours to do manually, you can do it in 20 seconds with Copilot. And now you can go ahead and add login systems. You can add a database. You can add an about page. And within 15 minutes, you can have a running app ready. So this is not like that something like a fancy thing we are trying to talk today, right? Now, because all these are something which I'm doing day in, day out. Now, this doesn't mean programmers will lose the jobs. Now, if I go back to my VS Code, there are a lot of innovations I can do because I have my the py file which is generated out of it. Suppose there is a problem in the code, you can just go and tell here, like, I have this problem, go and fix it. It'll go and fix also. So I was waiting if this was giving any error, so that you'll see how beautifully the system itself is going to look at. How do you add a database? If you have any kind of database which you have, like maybe your DB Lite or something, SQL or whatever is it, you can just write connect the app. You will not actually go and connect the thing. Okay. How to deploy to AWS, everything is possible. Now, basically, we don't have time to cover that. But what I was trying to teach you here is we spoke about prompt engineering. Now you can bring that not only into the space of creating new content, creating new text, you can also generate an app. Now this can be called as vibe coding because you can also speak to it. Because we can become more and more lazy, right? To tell that, can you do this? Now, to deploy to AWS, you can use Q Developer. Amazon Q, we have a separate session. So Q is where you will use it to do that. I want to end up the Sunday with this so that you know that these are all not fancy. And if anybody is interested to know how to do this and all, you can go and learn about a little bit of vibe coding, which is not part of the coverage which we will have. But knowing vibe coding is very, very important in today's world. Every vendor is using vibe coding. Basically, Google Cloud is using vibe coding. You can read the Wikipedia a little bit here and there. If whichever language you want to pick up, you can learn a little bit about vibe coding. My recommendation is to just learn it in generic, like a Wikipedia, like what it does. It gives you multiple options to tell that what it will do in the future, etc., etc. Okay. With that, let's wrap it up.
So that's all for today's deep dive. We have covered foundation models, transformers, prompt engineering, which is part of our AI ML beginners, and the real world applications. So now you have the knowledge to take your skills to the next level and apply them in your career. And remember, this is just a taste of what you learn in our AI/ML track job-oriented program, which has helped professionals like you secure high-paying roles and certifications in AI. And don't forget, we have got that free 90-minute masterclass coming up where we will give you a clear roadmap to landing a top AI job. So make sure to register through the link below. So thanks for watching. If you like this video, do subscribe to our channel and make sure that you watch our previous videos right over here.